The top athletes in the major sports leagues in the U.S. make enormous amounts of money, particularly in baseball. Since 2010, there have been 12 players who've gotten contracts worth over $200 million. For example, Miguel Gruber of the Detroit Tigers got a contract of $292 million over 10 years. At the time, it was the biggest in Major League history. But the contract didn't pay the money out all at once. He received $29.2 million per year for 10 years. How does the length of the contract matter? It turns out it matters a lot. The key insight is that money you get 1 year from now is worth less than money you get today. This is because of opportunity cost. If you have the money today, you can invest it in something profitable and end up with more than you started with at the end of the year. So $1 today can become more than $1 next year because you get the dollar back plus interest in a year. But if you don't get the dollar until next year, when next year comes around, you still just have that $1. That is, $1 received in the future is actually worth less than $1 received today, because $1 received today could be invested productively, but $1 received in the future can't. So if Miguel Gruber makes $29.2 million per year for 10 years, he can't really add up each year's salary to say he ends up with $292 million. That's because a lot of that money comes to him in the future and ends up being worth less to him. But how should Miguel decide whether he got a good deal? For example, what if instead of offering him $292 million over 10 years, the Tigers had offered him $200 million today? Should he take that deal? To make this comparison, we need some way of putting these different dollar amounts earned at different times into common terms. The way to do this is take each chunk of money he gets, look at it separately, and convert it into a common measure. It's a little like shopping at a grocery store. Imagine you have a bunch of apples, a steak, and a salad from the salad bar. They all get sold by the pound. But if you want to know how much your bill will be, you can't just plop them all down on the scale and look at the total weight. The total weight has no meaning because each substance has its own price per pound. That's why each substance must be weighed separately. Then you multiply the weight by the price per pound for each food, and the separate values add to determine the total cost. Since $1 in 20 years has a different value than $1 in 19 years, we need to find a way to translate all future dollars into today's terms. This is what we call present value, or the value of each period's payment in today's terms. How do we make this translation? Through the process of discounting. What we do is take each future dollar and penalize it by how far it is into the future. For example, suppose I offer you a choice of $100 today or $100 in 1 year. And suppose you could save the money at an interest rate of 10%. Well, if you take the $100 today, you could save it and have $110 next year. But if you take the $100 next year, you only have $100 next year. That is, the $100 received next year is only worth 100 over 110 compared to getting $100 today, or 90.9% as much. It's worth less because you paid the opportunity cost of not being able to invest it. More generally, $1 received in 1 year is worth 1 over 1 plus I as much as $1 today, where I is the interest rate you could earn on that money if you had it today. Money's worth even less if you get it further in the future. Suppose that I gave you a choice between $100 today or $100 2 years from now. Well, if I gave you that $100 today and you save it, you'll have $110 next year. Then if you save it again, you'll have 110 times 1.1 or $121 in 2 years. On the other hand, if you just get $100 2 years from now, you'll just have the $100. So that $100 2 years from now is only worth 100 over 121 compared to today, or 82.6% as much. For those who want to figure this out for any time period, you can use the formula PV, or present value, equals FV over 1 plus I raised to the power T, where FV is the future value of payment. So now we can go back to Miguel Gruber's question. If the Tigers offer him $292 million for 10 years, or just $200 million but all at once, which should he take? It might seem like $292 million is so much more money that it's a smart deal, but that's not necessarily right. For example, if the interest rate is 8%, then the $292 million over 10 years ends up being worth only $195 million in today's money. It turns out that having money today can be really valuable compared to getting it down the road. this comes up is for the lottery. The highest total for a single lottery winner was a jackpot of $600 million from Powerball, but that money got paid out in equal chunks over 20 years. If you assume the same discount rate of 8%, it turns out the $600 million jackpot was only worth $294 million in today's money. That is, since it's paid so far in the future, you forgo the opportunity cost to invest today, and therefore it's worth less, only half as much. Still not bad, but a lot less than it seems. Why is the gap between the jackpot and the actual present value so big? There's a very simple mathematical reason. It's called compounding. We'll discuss that in the next application.